Welcome to the Nickel City Line Railroad. Today we're going to talk about dispatching on the NCL. The role of the dispatcher is critical to daily railroad activities, both in the real world and for model railroad operation. Modelers utilize a wide variety of systems to dispatch their model railroads. Whether it is timetable train orders, centralized traffic control, or a modern computerized traffic control system, each one is critical to the success and enjoyment of model railroad operations. The Nickel City Line, or NCL, is a modern turn-of-the-century railroad set in early 1999. The railroad replicates a modern computerized traffic control system. In this video, we will provide a general overview of how to operate the railroad's dispatcher panel. Let's start with an overview of the dispatcher's console. The console contains two large computer monitors, in addition to several other electronic components. The lower computer monitor displays the Computer Assisted Traffic Control System, or CATS. This is a software system developed as an overlay to the Java Model Railroad Interface, or JMRI software, which runs the railroad. The screen displays a track schematic of the entire railroad layout. The upper monitor displays the TrainStat screen. TrainStat is an add-on to the CATS software. It reports train status, assigned crew, and the train location on the layout in real time. A fast clock is located underneath the lower screen. This is a product from Logic Rail Technologies and is tied into the DCC system and run under the JMRI software. Two closed-circuit TV monitors are located to the right of the fast clock. These monitor conditions in the towns of Underwood and Driftwood, which are located on the lower deck of the layout. On the upper monitor beneath the TrainStat window are several smaller windows which monitor the Digitrax LocoNet, control the fast clock, power control, and provide direct turnout control access as a backup to the CATS Computer Assisted Traffic System. Four radio channel monitors are located along the right-hand side of the upper monitor. These channels monitor real-time radio traffic from prototype railroads that are in the area modeled by the NCL. To the left of the fast clock are the FRS radios and chargers for the dispatcher, track authority desk, and train defect detector. On the wall to the left of the dispatcher is a clipboard with the track authority orders for each session, as well as other reference materials. On the wall to the right of the dispatcher is the dispatcher's phone, which is connected to an internal telephone network used for communications between the dispatcher, yardmaster, hostler, and several towns along the layout. Now let's take a look at how the dispatcher's panel works. The panel has a track schematic of the layout. Detection blocks are separated from each other in order to show block occupancy and train movement. When a block is not allocated, the signals will always show the most restrictive aspect, red, for stop. To reserve a block for a train, the dispatcher reserves a route by left-clicking the mouse when the mouse is positioned over an empty or off signal symbol. If the reservation is accepted, then the signal symbol changes color and the tracks composing the reserved route turn green with an arrowhead pointing to the exit of each block. When a train enters a reserved block, the tracks composing the reserved route turn red with an arrowhead pointing to the exit of each block. When a train exits a reserved block, the tracks composing the reserved route turn almond in color with an arrowhead pointing towards the exit of each block. This tells the dispatcher that the block must be released before it can be reserved again. There are two ways to clear a reservation. The dispatcher can cancel a reservation by clicking the left mouse button when positioned over a signal icon that is either green or yellow. Now let's look at a quick example of how the CATS system works on the dispatcher's console. A westbound train is located on the siding. Note the red block indicating it is occupied. An eastbound train is on the single-track main with an occupied block also noted in red. The dispatcher reserves the block at CP49 for the eastbound train. Then the dispatcher allocates the next two mainline blocks for the eastbound train. Note how the signals change as more blocks are allocated for the eastbound train. The westbound train is allocated a block up to CP49. However, because CP49 is allocated to the eastbound train, the dispatcher cannot move the turnout or allocate the CP49 block to the westbound train. This is one of the many safety features built into the CATS software. As the eastbound train progresses through the blocks, they turn from green to red to almond. This means that the blocks remain reserved for the eastbound train until released by the dispatcher. With the eastbound train now gone, the dispatcher must release the previous reservations in order to remove the turnout at CP49 and allocate CP49 and the single-track main to the westbound train. To do this, the dispatcher cancels the reservations by clicking the left mouse button when positioned over a signal icon that is green or yellow. The blocks then return to white and can be reallocated to another train. With the reservations released, the dispatcher can now reserve the selected blocks for the westbound train, at which point the westbound train is cleared to proceed. Now let's work with the dispatcher's console. To change the turnout must be unoccupied and unreserved. Simply move the mouse over the turnout and left-click the mouse. The turnout will change to the opposite route. Left-click the mouse again to move the turnout to the opposing route. If the dispatcher attempts to reserve a route with a conflicting turnout or reserved or occupied route, the CAT system will provide a pop-up window reporting the conflict. To reserve a route, the dispatcher will align the appropriate turnouts along the route to the desired path. Once aligned, the dispatcher will reserve the route by clicking on each signal head at the entrance to each block along the route. The blocks and signal will change color to green with an arrowhead in the direction of the allocated route. The dispatcher now has reserved the route for a train. Let's follow Amtrak train 650 as it departs Ridgeway and heads east to Montserrat.
Show employee Seckler and a 3091. If there's a correct, proceed to milepost when you're ready. I was going to just give you one segment at a time because I didn't want to give you a follow-up. I didn't want to talk to the 32, but I'll give you a little bit longer. 1 second.
With Amtrak 650 out of the reserved route, the dispatcher releases the reservations by left-clicking on each signal at the entrance to each block. This releases the reservation and the train segment returns to a white color. Let's quickly discuss some special functions of the CATS software. The first is block occupancy. If we need to manually occupy or unoccupy a block due to a block reporting error, the dispatcher can manually set the block state. To do this, the dispatcher places the mouse cursor over the desired block and right-clicks the mouse. A pop-up menu appears. Select Occupy Block. The block is now occupied. To change the status to an unoccupied block, simply repeat the process. In the pop-up menu, Unoccupy Block replaces Occupy Block as an option. Select Unoccupy Block, and the block is now in the unoccupied state. If the dispatcher needs to assign a train to a block, they have the ability to do so. The dispatcher places the mouse cursor over the desired block and right-clicks the mouse. A pop-up menu appears. Select Position Train and the Accept button. A second pop-up menu appears with a list of available trains. Click the desired train and then the Accept button. The train icon for the desired train is now added to the block. If the train icon does not automatically move with the train's movement, it can be repositioned by simply left-clicking the mouse on the train icon and dragging it to the desired location. On the NCL, we use track authority on several sections of the railroad. When a train is working within an area that has been granted track authority, the dispatcher may change the status of the track involved. To do this, the dispatcher places the mouse cursor over the desired block and right-clicks the mouse. A pop-up menu appears. Select Grant Track Authority and the Accept button. The block changes to a blue color indicating track authority is in the block. Any signals on either side of the block will display their most restrictive state, and the block with the track authority cannot be reserved for any other train or purpose. To remove the track authority, simply repeat the process. In the pop-up menu, Remove Track Authority replaces Grant Track Authority. Select Remove Track Authority and the block now returns to its current state. On occasion, the dispatcher may need to place a piece of track out of service due to maintenance or a defect. To do this, the dispatcher places the mouse cursor over the desired block and right-clicks the mouse. A pop-up menu appears. Select Place Out of Service and the Accept button. The block changes to a purple color indicating the track is out of service. Any signals on either side of the block will display their most restrictive state, and the block or blocks cannot be reserved for any other train or purpose. To remove the out-of-state status, simply repeat the process. In the pop-up menu, Remove Out of Service replaces Place Out of Service. Select Remove Out of Service and the block now returns to its current state. In Part 1, we covered the elements of the dispatcher's console, how the CAT system operates, how to throw turnouts, reserve routes, occupy blocks, add train icons, and place track authority and out-of-service restrictions within a block. In upcoming segments, we will cover how TrainStat works with the CAT software, and we will go over how to dispatch the railroad on the NCL.